Okay, try again. Good morning, everyone. Welcome to week 5 of the Internet of Things section. Have a bit of a push, please. Cheers, we can just keep it down. Going to have a look this week at another couple of demos to do with sensors. Show you those first. Finish off one section from last week that I didn't get through to, and then move over on to a sort of level above the technical section that we've been really dealing with so far. The last 2 weeks have been quite technical, looking at the actual connections involved and the setup required actually of the nodes and the network, that sort of thing. This week in the lab, you'll be running this lab exercise about Android to sensor server. You'll be writing an Android app to connect to your fidgets, both retrieve data about the fidgets and to send some data back to them, telling them to move, that sort of thing. I was talking with one of my project students who's got some friends in here, who said that 1 or 2 people were a bit surprised by this module, that they thought it was all about mobile phone programming. Because it was called mobile app development, they thought it was all sort of mobile phone programming. Now you can't get much more mobile than some of these sensors that we're dealing with, and you're writing apps for it. And some of the things we're looking at this week, this is a mobile device for like a sensor box for picking up data around your home for it. Another one here, a company called NetAtmo does a similar one. And we're writing software for these types of devices and building these sort of types of devices. You know, they are highly sort of mobile, yeah. I mean, admittedly, I guess people might have been confused by the name of it, thinking that mobile app meant mobile phone app. And you are doing some mobile phone app programming in the second semester. Here we're concentrating on, if you like, sort of truly mobile apps, getting away from the idea of having to use a screen. Now, as these things come round to have a look at, these are both sensor boxes. They pick up environmental data, and I'll talk about another one as well, and you'll feel as they come round that one's much heavier than the other for it. Both were started on Kickstarter. The one, the tall box, is this company called NetAtmo. They've become a lot more successful on what they do. They've branched out into a lot of other products. The other one, the Point, as it's called, hasn't quite got as many followers to it, but both are still sort of receiving crowdfunding. But I'll pass around what sort of data they send back. You'll feel a definite difference in weight, and there's a reason for that. The first one, just to have a look at, one of these ones is called NetAtmo. Atmospheric detection. They use it both for weather, energy monitoring, security monitoring. It's a French company. You might say that's reason not to buy off them, but French company that's doing very, very well for it. Now doing a range of devices. I think they've revamped the look of it. But if I just say, for example, show some of the ones I've got some dotted around my own place. That sensor that you've got there is an indoor sensor and detects environmental or atmospheric data such as temperature, humidity, air pressure, CO2 levels, sound levels. And this is just picking up on live what's happening in my own home for it. So say the temperature sensor there, since midnight, probably when you're sort of going to bed or something like that, the temperature's dropping down. Getting up in the morning, the temperature rises up as the central heating comes on, and then again sort of drifting out. Nothing really sort of surprising there for it. Humidity, that might go along with the cooking. CO2 levels. Everybody breathes, hopefully. So measuring CO2 levels there gives you an idea of who's about the place. So you can detect the presence of people, not just by whether or not there's movement, but by things like CO2 level. So this one's, I think, placed in the kitchen for it. So again, sort of overnight, drop right down. There might be a couple of cats wandering about or something like that, but pops up again in the morning. Why the sound level one bounces about all over the place, I don't know. I suspect it might be because there's a cat flap that makes a bit of a racket, so the cats are in and out all night. Is it sort of picking up on that? But that's a sort of idea just of what that thing's sending back. Now you'll find that particular device, the taller one, is lighter than the other because that uses the same type of network connection that we've been going over in some of the lectures. It doesn't broadcast out its signals direct to the internet. It broadcasts it through a little hub. You plug in a hub inside the house and all these atmospheric detectors talk to that one. So it doesn't need as much power to be able to send its signals to the sort of hub. So over on the right, there's I've got the sort of indoor one, and there's that one sort of connected to the Wi-Fi. It's complaining that the other indoor atmosphere meter it can't find. That's because it's here, sort of thing, so it can't sort of located. And I did have a rain gauge outside that was sending the sort of rain levels. Unfortunately, some of the storms, I didn't tie it down well enough and it blew off, smashed to pieces, so I sort of lost that one. But that works because the individual devices only need to send a short distance, they can work on smaller battery power. They're only using, say, low power Bluetooth or this Zigbee to communicate. The other one, and I'll show you a sort of demo in a second, the other one is much heavier because it's got 4 AA batteries in it. And that communicates with the Wi-Fi, so it communicates direct to the router. Whereas these ones bounce through a hub and then out to a sort of router. So they look, I don't know if I've still got something in one of these. I might have a diagram from the other day. This was a similar one for the central heating control that I think it's included in the assignment list to it, where you've got sort of nodes dotted around the house. They communicate with a centralised hub over some low power frequency. That thing's typically powered, so it can talk to this sort of internet gateway. Actually, I think that's battery powered. The internet gateway is the thing that's plugged in. So if you want to get out onto the internet, you've got to go through, typically connecting to your router. That's normally a Wi-Fi connection. If it's Wi-Fi connection, it's power hungry. So typically anything that's talking to your Wi-Fi either needs a power connection or not to do it so often. If it doesn't do it so often, that's a good idea. The other one, the heavier one that's going round, that only broadcasts out about every half hour what the current status of the room is, to sort of get round. But this is a very sort of typical system sort of diagram of how an Internet of Things device is laid out. And that's actually part of your assignment, is to take some existing node layouts and to try and specify this sort of layout about how they communicate. Who communicates using what type of radio communication? Is it Wi-Fi? Is it Bluetooth? Is it Zigbee? Do they send JSON messages to it? Do they use some sort of gateway to connect to it? So looking at a variety of nodes and sort of creating a little systems chart to help understand what the overall layout is. Now the other one, just to have a brief look at, the point one. Just bring that up. This is from a company called Minute, M-I-N-U-T, and I've got various ones of these point devices around the home. Again, I'll just sort of take one out, so some will be indicated as not there. So if I pick, say, Kate room there, Similar thing being transmitted out. Live transmission here, we're up to just after 12 o'clock. So what's been the noise levels in there, what's been the temperature level in there, the humidity level. That's a bit of an unoccupied room. She isn't living at home anymore, so it's fairly quiet in that one. The software's got a bit of glass break detection built in, and we're looking at these sorts of things just in either today's one or the beginning of next week, where you can decide, well, out of all that noise data, was there like a smash of glass in there, or a sudden sort of explosion of sound in some way to get to it. And again, they all come with looking at sort of weekly levels or monthly levels. I mean, looking over a month, you might sort of say, well, there, for the sound level, yeah, it's all pretty much of a certain thing, what's going on. But something around the 14th, 15th, went on for it there. I actually had visitors that weekend, and they stopped in that room. So there was a bit more activity going on. You can see the sound level was raised a bit. So what we can do with the data coming in is you can then perform some sort of analysis on that.